In this video, we will review the law of sines and how to find the area of a triangle using two sides and the included angle. First of all, remember that the law of sines is like this. A side divided by the sine of the opposite angle will be the same for every pair of side and opposite angle. So side A divided by the sine of angle A will equal side B divided by the sine of angle B, the opposite angle, which will equal side C divided by the sine of angle C. That's the law of sines. Now we can use the law of sines to find the length of side AB, which is also known as side C because it's across from angle C. And well, first of all, we need to find the missing angle A because all three angles add up to 180. If we subtract these two from 180, that'll give us the missing angle A. So let's do that. That gives us 16 degrees for angle A. So now we can set up the law of sines. Because I want to find a side, I'm going to make sure I put sides on the top in the numerator. So I can put 9 over the sine of 16 degrees. All right, I'm putting sides in the top because I'm looking for a side. And that's going to equal C over the sine of 63, the angle across from C. All right, there's my law of sines. Now, because I want to get C by itself, I'm going to multiply both sides by sine 63. That way, these will cancel each other out, and that will leave me side C, which is what I was looking for. So really, I just need to put this whole expression in my calculator, and that'll be the answer. Okay, I am getting side C is equal to 29.093. So that is the answer to problem number 1. All right, similarly, for problem number 2, I want to find the measure of angle A, and I'm going to use the law of sines to get it. Because I'm looking for an angle, when I set up my law of sines, all right, using these two quantities across from each other, I'm going to put angles in the top because I'm looking for an angle. So I'm going to say the sine of 104 over 30 is equal to the sine of angle A over 8. Okay, so since I need to solve for angle A, I need to get the sine of A by itself. I can do that by multiplying both sides by 8. So I'm going to multiply both sides of my equation by 8. That way these 8s are going to cancel each other out. So that gives me sine of angle A. But I don't want just the sine of angle A. I want angle A itself. So if I want angle A out of this, then I need to do the inverse sine of all of this. Okay, that will give me angle A. So I'm just going to put this entire expression in my calculator all at once. So I discover that the measure of angle A is equal to 14.996 degrees. And that's the answer number 2. All right, now as I move on to problems number 3. I'm being asked to find the area of a triangle given the information below. Now, this is not a right triangle, and I'm not given the height. Instead, I'm given an angle, and I'm given two sides and the included angle. So that reminds me that we need to go ahead and write down the formula for that. So here's one example of this formula for how to find the area of the triangle if we are given two sides and the included angle. So the area will equal 1/2 one side times the other side times the sine of the included angle. Now obviously there's nothing special about angle A. The side B and side C just represent the two sides, and angle A has to be the included angle. I could just as easily have used, for example, I could have used sides A and C. So I could have said 1/2 side A times side C. All right, and then B would be the included angle. Okay, or just for the sake of completeness, let's see. I could have used sides A and B. So I could have said 1/2 side A times side B times the sine of angle C. Any of these would give me the area of the triangle. So I need 1/2 side times the sine of the included angle, the angle in between. Okay, so that's what we're going to do for problem number 3. Okay, you can tell by the letters. See how we have A, C, and then angle B. See how we have 2 letters and then the third letter. That means we're going to have two sides and the included angle automatically. Okay, so the area will equal 1/2 one side times the other side times the sine of the included angle. And you could just put all this in your calculator and that'll be the answer. So we find that the area is equal to 5.979. Okay, and this is units squared. All right, and I feel like drawing a diagram just one time here. So this would have been, I could have put angle A, B, and C like this. That would make this the 26.8. Of course, side A is across from angle A, so the 3.4 would have been here. Side C would be across from angle C, so the 7.8 would be here. And notice, as I mentioned before, I have two sides and the included angle, the angle in the middle. All right. Now this is a little different. I don't have two sides and the included angle. I have two angles and a side. So I'm going to have to do some additional calculations. So I definitely want to go ahead and draw myself a diagram. Okay, so angle A, B, and C. And so we're given that angle A is 35.5 degrees. Angle B is 46.6 degrees. And we're given side C, which is across from angle C, is 8.1. Okay, we are going to need another side, either one of these sides. So we will have two sides and the included angle. But in order to find another side, we first will have to have angle C. But that's easy because all of these have to add up to 180. So I can just subtract these from 180, and that'll give me angle C. So that turns out to be 97.9 degrees. See, I needed that because now these are across from each other. I can now do the law of sines. So I'm going to pick either one of these sides to find. I think I'll go ahead and find side A over here. All right, could have found side B, doesn't really matter. Because I'm looking for a side, I'm going to put sides on the top. Okay, so I'm going to say 8.1 over the sine of 97.9 is equal to side A over the sine of 35.5. So if I want to solve this for side A, I can just multiply both sides by the sine of 35.5. That way these will cancel each other out, and that will leave side A. So I'm just going to put this whole thing in my calculator at once. All right, I am getting that side A is 4.749. Okay, so actually I think I'll go ahead and just erase this, and I have now found that this is 4.749. Had to round up. Okay, that puts me in a position to find the area of the triangle, which is what I really wanted to find. Okay, so now I can say the area is equal to 1/2, and I'm going to do 8.1 times 4.749, and then times the sine of the included angle. So the sine of 46.6. And I'm just going to put all that in my calculator. I am getting 13.975 square units. All right, for problems number 4, we need to solve these triangles. Notice that there's no way that we have to worry about the ambiguous case. The ambiguous case is only when we have side-side angle. Here we have two angles and a side. So this is not the ambiguous case, so there will be a triangle and only one triangle. So it's going to be pretty straightforward. All right, so we can just go ahead and draw our diagram and get busy. Okay, so here's our diagram. Let's see, so I have angle A. All right, I'm just going to go ahead and call this angle A, angle B, and angle C. So angle A is 22 degrees. Angle C is 13 degrees. And side C is 9. So that's going to go right here. All right, we need to solve this triangle. So the things that are missing, we're missing angle B, so we're going to have to find the measure of angle B. We are missing side A, so we're going to need to find side A. And we're missing side B. So these are the three quantities we will need to find in order to solve this triangle. Okay, so first let's go ahead and find angle B. We can just subtract these two from 180, and that'll give us angle B. So angle B is 145 degrees. All right, so clearly this picture is not really drawn right because this should be an obtuse angle of 145 degrees. And if we wanted, we could redraw this, but I don't think it's going to matter in terms of finding these lengths. Okay, so let's go ahead and use the law of sines. I see I have the angle and the opposite side right here, angle C and side C. So I'm going to use that when I do my law of sines. Because I'm looking for a side, I think I'll go for side A, I'm going to put sides on the top. So I'm going to say 9 over the sine of 13 degrees is equal to, and so that'll be side A, which looks a little bit like a 9, but side A over the sine of angle A, which is 22 degrees. So if I want to solve this for side A, then I need to multiply by the sine of 22 degrees on both sides. That way these will cancel each other out, and that will give me side A. So I'm going to put this entire expression into my calculator right now. So I just got 14.988 for side A. Okay, now I'm going to do the exact same thing to find side B. So again, I'm going to do 9 over sine 13. But this time I'm going to do side B. So I'll do side B over the sine of 145 degrees. All right, just like last time. So again, to get side B by itself, I need to multiply both sides by the sine of 145. All right, so these will cancel each other out, and that will leave me with side B by itself. So I'm going to put this entire expression into my calculator, and that will give me side B. And that is 22.948. So we just solved this triangle for 4A. All right, I think I'm going to just do one more problem on this video. Okay, so here I have two angles and a side. So again, this is not side-side angle. I do not have to worry about the ambiguous case. I can just draw the picture and solve it. There will be one solution. That's it. Okay, so here's my diagram. Okay, so I'll just say angle A, B, C. Angle B is 35 degrees. Angle A is 91 degrees. Okay, so this really should have been obtuse, but I don't think it's going to affect the calculations. And side C is 15.5, so I'll put the 15.5 across from angle C. Okay, so let's set up our solution box. I'm going to need the measure of angle C. I'm going to need side A. And I'm going to need side B. So once I find these three things, I will have solved this triangle. Let's start by finding angle C, because I can just subtract these two angles from 180, and that'll give me angle C. So that turned out to be 54 degrees. All right, now let's go for side A. So I've got this angle and the opposite side. So I'm going to do the law of sines now. Because I'm looking for a side, I'm going to put sides in the top. So that's why I'm going to do 15.5 over the sine of 54. And that's going to equal side A over the sine of 91. Okay, so if I want to get side A by itself, I need to multiply both sides by the sine of 91 degrees. So these will cancel each other out, and that will leave me with side A. So I'm just going to put this entire expression in my calculator all at once. That gives me 19.156 for side A. I'm going to do the exact same thing for side B. And again, since I'm looking for a side, I'm going to put sides in the top. So it'll be the exact same thing. 15.5 over sine 54. But this time I'm looking for side B, so I will say side B over the sine of 35. All right. To get side B by itself, I need to multiply both sides by the sine of 35. So these will cancel each other out, and that's going to give me side B. So I'm just going to put this entire expression in my calculator all at once. So that's going to give me 10.989 for side B. And there we have solved this triangle. Problem number 5, give the angle in the second quadrant that would have the same sine value as the given angle. First one is done for you. Well, let's look at that. Given a 20-degree angle, the question is, what would be an angle in the second quadrant that would have the same sine as this? Now, remembering that the sine is the y value, all right, that's the height of this point. We're looking for the same y value in the second quadrant. So if I made sure that this angle, here I'll use a different color, this angle had the same height, all right, like the same height. So I'm talking about this angle right here. Okay, now the only way this angle is going to have the same height is if this is also 20 degrees down here. All right, if this is 20 degrees, this is also 20 degrees away from the x-axis. Okay, but I don't want this. I want to know what this green angle is. Well, hopefully you can see that all I have to do is subtract from 180. So if I do 180 minus 20, it's 180, then that's going to give me 160. So that tells me that this green angle here must be 160 degrees. All right, so I can get an angle in the second quadrant that has the same sine by subtracting from 180. All right, and that's how we got 160. Once you have that understanding, the rest of these become trivial because we're just doing 180 minus 50. So that's 130 degrees. And then we'll just be doing the same thing for all the rest. So just taking a quick tour, 180 minus 85, 95. 180 minus 10, 170. 180 minus 18, 162. 180 minus 77, 103. 180 minus 30, 150. 180 minus 60, 120.